Hey all. So today we are going to look into the Ncert textbook problems of the chapter Some Basic Concepts of Chemistry. If we look into the textbook, question number 1 says, calculate the molecular mass of the following. First one is H2O, second one is CO2, and third one is CH4. Now I'm going to explain how do we approach such a problem. We are being asked to find the molecular mass. So the first concept that we should be aware of is about molecular mass. So what is this molecular mass? Molecular mass is the sum of atomic masses of each element present in the molecule. For example, for us we have the first question as H2O. So as I said, molecular mass is the sum of atomic masses of each element. Here we have two elements, hydrogen and oxygen. So the molecular mass is the sum of the atomic masses of both this hydrogen and oxygen. Now, I was repeatedly saying the term atomic mass. So what is this atomic mass? Atomic mass, or other ways we can say, as the mass of an atom is very small. Why? Because the atom in itself is very small. So its mass will also be very small. The present system of atomic masses is based on carbon-12 as the standard. This carbon-12 is an isotope of carbon which can be represented as 12C. And this 12C is assigned a mass which is exactly equal to 12 atomic mass unit or AMU. So from this we can define 1 AMU as a mass which is exactly equal to 1 by 12 the mass of one carbon-12 atom. And this 1 AMU is calculated to be 1.66056 into 10 power minus 24 gram. And this value is an average of the proton and neutron rest mass of this carbon-12 atom, which is calculated to be 1.66056 into 10 raised to minus 24. Let us move ahead with the questions. First question is H2O. To calculate the molecular mass, we have to add up the atomic masses. Now we have the atomic mass of hydrogen to be 1.008 AMU and oxygen to be 16.00 AMU. To find the molecular mass, we have to add these two values. But since we are given two hydrogen atoms, we have to multiply this value with 2. And then add the 16.00, which gives us a value of 18.016 AMU. And this is the molecular mass of H2O. Now, the next question is CO2. We have the atomic mass of carbon to be 12.01 AMU and oxygen 16.00 AMU. To find the molecular mass, as we have done earlier, we have to multiply 2 atoms of oxygen. So we have 2 into 16.00 AMU plus 12.01 AMU, which is giving us a total of 44.01 AMU. Now for CH4, we have carbon 12.01 AMU. Now we have hydrogen, that is 1.008 AMU. Here we have 4 atoms of hydrogen, so we multiply 4 into 1.008 plus 12.01 AMU, which is giving us a total of 16.042 AMU. Hence we calculated the molecular mass of each of this molecule. I hope this question is clear. Let's move ahead with the next question. Question number 2 says, calculate the mass percent of different elements present in sodium sulfate, Na2SO4. So here we have to calculate the mass percentage of sodium, sulfur and oxygen of the compound Na2SO4. We have learned an equation to find the mass percentage of an element, which is mass percentage of an element is equal to mass of that element in compound divided by molar mass of the compound into 100. So here we need to first calculate the molar mass of the compound. Molar mass is the mass of 1 mole of a compound. So we are going to first calculate the molar mass of this compound, that is Na2SO4. So we have the atomic mass of sodium as 23, sulfur as 32 and oxygen as 16. With this information, we can calculate the molar mass. Since we have 2 atoms of sodium, we multiply 23 into 2 plus we add the atomic mass of sulfur, that is 32, plus we add 4 into 16 because there are 4 atoms of oxygen, and then solving this, we have 142 gram per mole, and this is the molar mass of the compound Na2SO4. Mass percent of sodium, that is mass of sodium in compound. Since we have 2 atoms of sodium, that is 2 into 23 divided by molar mass, which we have already calculated, is 142 into 100. Solving this, we get 32.39%. Similarly, mass percentage of sulfur. Here mass of sulfur is 32 divided by molar mass 142 into 100, which is 22.54%. Last, mass percentage of oxygen. Since we have 4 atoms of oxygen, that is 16 into 4 divided by 142 into 100, and that is 45.07%. Hence we calculated mass percentage of each of the element sodium, sulfur, oxygen in the compound Na2SO4. Question 3 says, determine the empirical formula of an oxide of iron which has 69.9% of iron and 30.1% of dioxygen by mass. So here we have to calculate the empirical formula. So what is this empirical formula? Empirical formula gives us the simplest whole number ratio of various atoms present in a compound. So here we have iron and oxygen. So we have to find the simplest whole number ratio of iron and dioxygen present in this oxide of iron. Let's start. To answer this, it will be easier if we follow the tabular method. For this, we need to make 7 columns. The first column is element, next is simple, next is percentage by mass, atomic mass, moles of element, simplest molar ratio and simplest whole number ratio. Here we have the element iron and oxygen. Symbol of iron is Fe, symbol of oxygen is O. Now percentage by mass. It's already mentioned in the question. For Fe, the percentage is 69.9% and for oxygen it is 30.1. And we know the atomic mass of iron is 55.85 and oxygen is 16.00. To find the moles of the element, we have to simply divide the percentage by mass by this atomic mass for each of this element. So for iron it will be 69.9 divided by 55.85 and for oxygen it will be 30.1 divided by 16.00. So this answer will be 1.25 and this will be 1.88. To get the simplest molar ratio, we have to divide these two values by the smallest among this. So here we have 1.25 and 1.88. The smallest among this is 1.25. So we divide both this 1.25 and 1.88 with 1.25. So we get this answer 1.25 divided by 1.25, that is 1, and 1.88 divided by 1.25 is 1.5. Now the last column is simplest whole number ratio. Since this number is in decimal and this is a whole number, to convert this number into a whole number, we have to multiply it with a number such that this 1.5 will be a whole number. So we know that 1.5 into 2 gives us 3, which is a whole number. So what do? We multiply this 1.5 with 2. When we are multiplying 1.5 with 2, we have to multiply this 1 also with 2. So if in a case we have to multiply it with 4 to get a whole number, we have to multiply both this one, the first element and the second element. If there are 3 elements, all the 3 elements with that particular number. So in this case, we are going to multiply both 1 and 1.5 with 2. So we get 1 into 2, which gives us 2, and 1.5 into 2, which gives us 3. So the simplest whole number ratio is 2 and 3. So the empirical formula would be Fe has 2 Fe atoms, so Fe2, and there will be 3 oxygen atoms, so will be Fe2O3. So the oxide of iron that we were talking about is Fe2O3. So such questions will be easier to solve and will be less mess if we follow this tabular method, which is very easy and convenient. Hence we calculated the answer as Fe2O3. Question number 4 says, calculate the amount of carbon dioxide that could be produced when, first one, 1 mole of carbon is burned in air, second one, when 1 mole of carbon is burned in 16 gram of dioxygen, and third one, 2 moles of carbon are burned in 16 gram of dioxygen. To answer such a question, first we have to write the balanced chemical equation during the combustion of carbon in dioxygen or air. So the equation is carbon, which is in the solid state, react with oxygen, which is in the gaseous state, to give you carbon dioxide, which is again in the gaseous state. Here we know that only 1 mole of carbon is being reacted, again 1 mole of oxygen and 1 mole of carbon dioxide is formed. Here the atomic mass of oxygen is 32 gram and for carbon dioxide it is 44 gram. This is the knowledge that we know from the balanced chemical equation. To further proceed, question number 1 says 1 mole of carbon is burnt in air. We know it's already given in the equation. Here 1 mole of carbon is burnt with 1 mole of oxygen to give you 1 mole of carbon dioxide. That is, it is producing 44 gram of carbon dioxide, which is a very direct question which we can answer from the balanced chemical equation. Second one says 1 mole of carbon is burnt in 16 gram of dioxygen. That is, only half of this amount of dioxygen is given. So the product formed will also be half. That is, this is the concept of limiting reactant, which we have already learned. The concept of limiting reactant says the reactant which is present in the lesser amount, here which it is oxygen, gets consumed after some time, and after that no further reaction takes place. Such a reactant which gets consumed in the reaction is called as limiting reactant. Here we can say only 16 gram of dioxygen is available. So the reaction will take place only for the 16 gram of dioxygen. That is, 16 is half of this. So again only we will get half of this amount of carbon dioxide. That is 22 gram. In the third question, we have 2 moles of carbon burned in 16 gram of dioxygen. Again, oxygen is the limiting reactant. We have only 16 gram of dioxygen. 16 gram of dioxygen will react only with half of the amount of carbon, because only half of the amount of oxygen is available. We will only react with half of the amount of carbon. That is 0.5 mole of carbon only will be reacted. Hence, we will again get 22 gram of carbon dioxide. I hope this question is clear. Let's move ahead with the next question. Next question says, calculate the mass of sodium acetate, that is CH3COONa, required to make 500 ml of 0.375 molar aqueous solution. Molar mass of the sodium acetate is 82.0245. This 0.0375 molar aqueous solution means that in 1000 ml of the solution, it contains 0.375 mole. So here we are asked about 500 milliliter of solution. So that will be exactly half of this. So it will contain 0.375 divided by 2 number of moles. And we are already given that the molar mass of sodium acetate is 82.0245 gram per mole. Therefore, the mass of sodium acetate required will be, it's very easy, you just have to multiply it. Here the number of moles of sodium acetate will be 0.375 divided by 2 for 500 ml of solution. We multiply it with the molar mass of sodium acetate, that is 82.0245. Hence, we get the answer as 15.380 gram. This is the amount of sodium acetate required in 500 ml of solution. I hope these many questions that we solved today is clear to everyone. If there is any doubts, you can come and ask in the comment section. We'll continue this NCERT solutions in the next session as part 2. Thank you for your time.